Hello students, welcome to Focus Math Plus. This is the third session of Chapter 3, The World of Numbers. As you know, the previous exercises, exercise 3.1 was based on natural numbers and whole numbers, and exercise 3.2 was based on integers, and this exercise 3.3 is based on rational numbers. So in this session, we are going to learn about rational numbers and also discuss questions from exercise 3.3. So let's begin. Before we start working the questions on the exercise, it's important that we recap the classification of numbers. As you know, the complex numbers comprise of the real numbers and the imaginary numbers. And under the real number system, we have the rational numbers and irrational. So we're going to learn about the rational numbers in detail. And you must be knowing that rational numbers comprise of natural numbers, whole numbers, and also integers. As we have learned in the previous sessions that the natural numbers comprise of the numbers starting from 1, 2, 3, 4, and so on, and whole numbers comprise of all of the natural numbers in addition to the number 0. And also integers comprise of all of the whole numbers in addition to the negative integers as well. And in this lesson, we shall be mainly focusing on rational numbers that includes all of those whole numbers, integers, as well as the fractions as well. So, what is a fraction? Numbers that represent part of a whole are called as fractions. As in this example, you could see that the three parts of the four parts have been shaded. So, this is represented as 3/4. And what are the real life applications of fractions? Like, say, if a farmer divides a field of wheat among his three children, how much does each one get? So it is three children and it has to be divided. So it's 1 over 3. So because it has to be divided into three parts. Another example, if a recipe calls for half of a cup of ghee, how would you represent this mathematically? So that's going to be a half of the cup. So all of these are the real life applications of fractions. Just as every natural number has an additive inverse. So what does an additive inverse mean? So suppose, say for example, if you have the number 3 and the additive inverse of the number 3 is negative 3. So if you combine both of these numbers, the result is 0. So since because the result is 0, these are the inverses of one another, 3 and negative 3. And likewise, the fractions also has its additive inverses. Like for a positive fraction, the negative fraction is its additive inverse. For this fraction 3/4, the additive inverse is negative 3/4, and both of these together would make a 0. And the negative sign, it could be placed with either in the numerator or in the denominator or in the middle. It all means the same. So when we combine all of the integers and all fractions, both positive and negative, we get the rational numbers. And it is denoted by the letter Q for the quotient. And the definition is a rational number is defined as any number that can be represented in the form P over Q, where P and Q are integers, which means it can be positive or negative, and Q should not be equal to 0. Think and reflect. The condition q not equal to 0 is necessary because we need q not equal to 0 in the definition of rational numbers, because dividing by 0 is not defined, which means it is undefined. So division by 0 is undefined. P over q does not represent any valid number. Without this condition, rational numbers would not have well-defined values. So therefore, a rational number is defined as P over q, where P and q belongs to the integers and q is not equal to 0. So real life connection, you could see that imagine dividing 12 apples among three children. So if there are three children, 12 divided by 3, so each one gets 4 apples, correct? And if each child gets 4 apples, but what does it mean to divide 12 apples amongst 0 children? 12 divided by 0. So there's no sensible answer to this question because there are no groups to distribute the apples into. So hence it is undefined, and that's the reason we shouldn't have the denominator q to be as 0. Here are few important observations at this stage. The first of which is that all the whole numbers could be represented as fractions. Like all rational numbers can be written in the form P over Q. Now say for instance, if you have a whole number 5, 5 could be represented as a fraction and hence it is a rational number. If you have a negative integer, say negative 7, this could also be written as a fraction as negative 7 over 1, because any number divided by 1 gives you the same number. So hence all natural numbers are also rational numbers, right? The second observation is that rational numbers do not have a unique representation in the form p over q, where p and q are integers and q not equal to 0, which means that the same rational number can be written in many different ways as a fraction. In this example given, you could see that negative 13 over 15 is a fraction, and from this fraction, different equivalent fractions are being generated by either multiplying by 2 or dividing by 3 or also multiplying by 3. So when we do these to the numerator and the denominator, we get many such equivalent fractions. Like say for instance, if you take a smaller fraction, say 1 over 2, you can generate an equivalent fraction by multiplying the numerator and the denominator by the same factor. For example, 5. So that's going to give you 5 over 10. And when you multiply this by 3, you could get 15 over 30. So all these are equivalent fractions and these are being generated from one single fraction. And when you simplify these equivalent fractions, you shall be getting the same fraction from where we started. So hence the statement, the same rational number can be written in many different ways as a fraction. The third observation is that the common understanding is when we say that p over q is a rational number, or when we represent p over q on a number line, we assume q not equal to 0, the denominator shouldn't be 0, and that p and q have no common factors other than 1, which means they are co-prime. Say for example, if you have these values 1 over 2, 2 over 4, 3 over 6 and 6 over 12. While you divide these, if you're going to simplify them, you could see that 6 over 12, it simplifies to give you 1 over 2 because 6 could be divided by 6 and 12 also could be divided by 6. So when you simplify all of these fractions, you are going to get 1 over 2 in the simplest form. So which means that only the simplest form of the fraction is being plotted on the number line, and hence these fractions should be co-prime, which means the two numbers are co-prime if their only common factor is 1. Example, 1 and 2 have no common factors other than 1, so they are co-prime. 2 and 4 are not co-prime because they both have the common factor as 2. Say, for instance, if you have the numbers 7 and 15, these are co-prime because there is no other common factor other than 1 which would divide both of these numbers. While the numbers 12 and 18, these are not co-prime because there exists a common factor which would divide both of these numbers other than 1, and which is 6 in this case, the greatest common factor. This would be reduced to 2/3. So 12 and 18 aren't co-prime, but 7 and 15 are co-prime because they just have one common factor, which is 1. So hence every rational number has many equivalent fractions, but we usually represent it by its simplest co-prime form. So the fractions have to be in its simplest form. So there are few laws of operations on rational numbers. The first of which is the equality law. Two rational numbers a over b and c over d are said to be equal if a times d is equal to b times c, which means the product of the extremes, a and d are extremes, b and c are the means. So the product of the extremes must be equal to the product of the means. In this example, 2 and 9 are the extremes. So 2 times 9 is 18 and the means are 6 and 3. 3 times 6 is 18. So both of these give you 18. So which means that these two fractions are equivalent. Addition and subtraction of two rational numbers. So when we are adding or subtracting two fractions, we need to ensure that both of the denominators are just the same. So we first express the two rational numbers as fractions a over b and c over b with the same denominator b. So we use the rules a over b plus c over b equals a plus c over b. We copy the denominator while we add the numerators. So when we are subtracting fractions, we just copy the denominator and we subtract the numerators. So we have to ensure that the denominators are common while we add and subtract fractions. The next law, multiplication and division of two rational numbers. So we use the rules a over b times C over D. So how do we multiply? The strategy is we multiply the numerators together and we also multiply the denominators together. So A times C, AC, and B times D, BD, where B and D shouldn't be equal to 0, which means the denominators should not be 0. We can just look at an example here. 2/3 times 3/5. We multiply the numerators together. 2 times 3, which is 6, and 3 times 5, which is 15. And this could be further simplified by dividing both of these by the greatest common factor, which is 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. The last one, with the arithmetic laws defined as above. Addition and multiplication are both commutative. As for the whole numbers, 7 plus 5, as it is same as 5 plus 7. So what is commutative property? Commutative property is when the numbers swap their places. So it is true because 7 plus 5 is also 12 and 5 plus 7 is also 12 because the order in which you add or multiply doesn't affect the result. 7 times 5 is same as 5 times 7. 7 times 5 is also 35 and 5 times 7 is also 35. So the order in which you multiply or add doesn't affect the result. But for subtraction, 7 take away 5 is not same as 5 take away 7. The solution to the one on the left hand side is 2, while the solution to the expression on the right hand side is -2. So they aren't equal. And similarly with division also, 10 divided by 2 is not same as 2 divided by 10. So 10 divided by 2 is 5 and 2 divided by 10 is 0.2. So hence these are also not the same. So it isn't true for subtraction and division. It only works for addition and multiplication. So that's the commutative property. So rational numbers are closed-ended addition, subtraction, and multiplication. That is, if one adds two rational numbers or subtracts two rational numbers or multiply two rational numbers, the result is always a rational number. Rational numbers are also closed under division, provided the denominator is not 0. Now that we have got to know what are rational numbers and also how to perform operations on rational numbers, we can start discussing the questions on this exercise. Exercise 3.3. The first question is, prove that the following rational numbers are equal. So we just go back to the previous laws. The first law, wherein we had the equality law. The two rational numbers a over b and c over d are equal if a times d is equal to b times c. So we are going to use this law to solve the first question in this exercise. So the cross product is to be found. 2 times 6 and 4 times 3. They have to be equal. So when you multiply 2 with 6, you get 12, and 3 times 4 is also 12. Hence, they are equal. The second subdivision, 5 with 8 and 10 with 4. 5 times 8 is 40 and 4 times 10 is also 40. So hence, because their results are the same, they are equal. The third subdivision, we have two negative fractions. So this negative sign could belong to either the numerator or the denominator. Let's consider it as -3. So -3 times 10 and -6 times 5. So both of these give you the result as -30. Hence, these fractions are also equal. The last subdivision, we see that there's a whole number here. This whole number 3 could be written as a fraction over 1 because any number divided by 1 gives back the same number. So we could just multiply 9 with 1 and 3 with 3. 9 times 1 is 9 and 3 times 3 is also 9. Hence, these are also the same, which means these fractions are also equal. Let's move on to the second question. So here we have been given fractions and we are to find out the sum of these fractions. What is the first requirement for adding and subtracting fractions? The denominators must be the same. So in the first question, the denominators are different. We have 5 and 10. So we have to find out the least common multiple of both of these values, LCM of 5 and 10. So there are many ways to find out the LCM. The easiest of all is listing down the multiples of 5 and 10 and then picking the least and the common multiple. So write down the multiples of 5. 5 times 1 is 5, 5 times 2 10, 5 times 3 15, 5 times 4 20, and so on. Multiples are many, but factors are few. So you shall be getting a non-ending list of multiples. 10 times 1 is 10, 10 times 2 20, 10 times 3 30, and so on. So now we are to pick the least and the common multiple. So the least and the common multiple, you could see that it is 10. So 10 is the least common multiple of 5 and 10. So what is that we need to do? We have to make the 5 as 10. So what should I multiply by 5 to make it a 10? Yes, it is 2. So I multiply 5 with 2 to make the denominators common. But I also have to multiply the numerator by 2 because only then the fraction's value will remain unchanged. So 2 fifths times 2. 2 times 2 is 4 and 5 times 2 is 10. I don't have to do anything with the second fraction because it is 3 tenths, and just to add the numerators, 4 plus 3 is 7, and copy the denominator. So we add the numerators and we then copy the denominator. So it is 7 tenths. The second question, we have 7 twelves and 5 eighths. Here again, we see that the denominators are not common. The denominators are not the same. So we have to find out the LCM of 12 and 8 and multiply the denominators accordingly to get the common denominator. Now let's list down the multiples of 12 and 8. The multiples of the number 12, 12 times 1, 12, 12 times 2, 24, 12 times 3, 36, 12 times 4, 48, and so on. Multiples of 8, 8 times 1, 8, 8 times 2, 16, 8 times 3, 24, and so on. So as you could see that there is a least and a common multiple, which is 24. So 24 is the least common multiple of 12 and 8. So I need to think about what number should I multiply by both of these denominators so that I get a 24. 12 times 2 is 24 and 8 times 3 is 24. But I also have to multiply the numerators according to the respective factors. So 7 is to be multiplied by 2 because 12 is multiplied by 2. 5 is to be multiplied by 3 because 8 is to be multiplied by 3. And the resultant fractions are 7 times 2 is 14 and 12 times 2 is 24. 5 times 3 15, 8 times 3 24. We then just to add the numerators, 14 plus 15 gives us 29 and 24 is just copied. So the denominator is just copied but the numerators are being added. This is an improper fraction, which means that the numerator is larger than the denominator. So it's always recommended that you write the improper fractions as mixed numbers. How do we do that? Divide 29 by 24. 24 divides 29 just once. So if I subtract, I get the remainder as 5. So 1 is the quotient, Q. The remainder is 5 and the divisor is 24. So we write it in this form, Q R D. Quotient is 1, so we write the 1. The remainder is 5, it's written above, and the divisor is 24. So this is 1, 5 over 24, and this is called a mixed number because mixed numbers are a combination of a whole number and a fraction. So this is a mixed number. The third subdivision, we have a negative fraction and a positive fraction. So this would eventually result in a subtraction problem. But before that, we need to have common denominators. Here we have 7. So I need to think about a number which I should multiply by 7 to get 14, and which is 2. So I multiply both the numerator and the denominator by 2. 4 times 2 is 8. 7 times 2 is 14. And this is done. I don't have to do anything with the second fraction because the denominator is already 14. So negative 814 plus 314. Since because one number is negative and the other is positive, the signs are different. So when the signs are different, we subtract the smaller number from the larger and we take the sign of the larger number. So 3, if you subtract from 8, you get a 5. But since because 8 is a larger number but it is a negative value, we take the negative sign. Because we have 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8. And of the 8 negatives, if I cancel 3 negatives, because I have 3 positives, each positive will cancel each negative. So the remaining is 5 negatives. So the answer is negative 5 over 14. And this is a proper fraction, and I can stop here. The next question, it is to find out the difference between the two given fractions. And the first rule is that we need to have common denominators. So 6 and 4, we have to find out the LCM of 6 and 4. So list down the multiples of 6 and list down the multiples of 4. And when you do that, you get to know that the multiples of 6 and 4, the least and the common of them is 12, because 6 times 2 is 12 and 4 times 3 is also 12. So multiply 6 with 2 and 5 also with 2. So 5 times 2 is 10, 6 times 2 is 12, and we're multiplying 4 with 3 because we need to get 12, and multiply the numerator also by 3. 3 times 1 is 3. Now, since because this is subtraction, we subtract the numerators alone. 10 take away 3 is 7, and we copy the denominator. So the denominator is 12. So 7 twelfths is the answer. The second question, 8 and 4 are the denominators. Now just think about for a second, what is the least common multiple of 8 and 4? List down the multiples of 8 and list down the multiples of 4 and see which is the least and the common multiple, right? So it is 8 because 2 times 4 is 8, and the second fraction is already having a 8, so we don't have to multiply. So we need to also multiply the 3 by 2. 3 times 2 is 6 and 4 times 2 is 8. And so since because this is a subtraction problem, we have to subtract 6 from 11. And 11 take away 6 is 5, and 5/8 is the answer. The third subdivision, we have to be careful that we have two consecutive negatives. Like subtracting a negative is like adding a positive. Subtracting a negative number is like adding a positive number. So this is the one way you could remember, or the other way is you could just understand that two consecutive negatives, they make a positive. So you can just remember it this way, that two consecutive negatives makes a positive. So these two come in a row. These two negatives are in a row, so they make a positive. So we see that one fraction is negative and the other is positive. And yes, again, we have to find out the LCM of 9 and 3, which is obviously 9 because 3 times 3 is 9. So we multiply the second fraction by 3. 2 times 3 is 6 and 3 times 3 is 9. And we are going to subtract. We have 7 negatives, 1, 2, 3, 4, 5, 6, 7, and we have 6 positives, 1, 2, 3, 4, 5, 6. So each negative will cancel out each positive. So when this is done, I'm just left with one negative. So the answer to this question is negative 1 over 9. And hence it is a proper fraction. And with that, we stop. Now, multiplication and division of fractions. So there are strategies to multiply and divide fractions. The strategy is multiply the numerators together and multiply the denominators together, and you get the answer. Simplify if possible by the greatest common factor. And the strategy to divide is keep, change, flip, which is KCF. Keep, change, flip. We keep the first fraction as it is. We change the division sign to multiplication sign, and we flip the second fraction, which means we write the reciprocal of the fraction. So the reciprocal of 2/3 is going to be 3 over 2. Reciprocal of 5/7 is 7/5. So it's just a flip of the fraction. So keep, change, and flip. Now let's discuss the next question, which is based on this strategy. Find the product. Product means multiplication. So we just multiply the numerators together, 2 times 3, and multiply the denominators together, 3 times 10. So 2 times 3 is 6 and 3 times 10 is 30. So the answer is 6 over 30. But it should be reduced. So you can divide this by the greatest common factor, which is 6. 6 divided by 6 is 1 and 30 divided by 6 is 5. So the answer is 1/5. In the second subdivision, we to see that it is 7 11s and 5 8s. So multiply the numerators together, 7 and 5. 7 times 5 is 35 and 11 times 8 is 88. And these cannot be simplified further because there's no other common factor other than 1 and hence they are co-prime. The next question, negative 4 times 5, which is negative 20, and 7 times 14, which is 98. This could be reduced. You can divide that by 2. 2 is the greatest common factor. And we get the answer as negative 10 over 49. The next question, which is to find the quotient. Quotient means the answer to a division problem. You have to divide these fractions. So what is the strategy? Keep, change, flip. So we keep the first fraction, which is k. Next, it is C, which is change the sign to a multiplication sign. So division changes to a multiplication sign. And the last one is F, which is flip, flip of fraction. So 3/10 is written as 10 over 3. So keep, change, flip. Now you could see that this is a multiplication problem. And how do we multiply fractions? We multiply the numerators together and we multiply the denominators together. And it's very easy. So we do the keep, change, flip, keep the first fraction, change the division symbol to multiplication, and flip the second fraction. So 2 times 10 is 20, and 3 times 3 is 9, 20 over 9. But you could see that this is an improper fraction because the numerator is larger than the denominator. So what is that we have to do? Convert this to a mixed number. How do we do that? We divide. 20 divided by 9. 9 divides 20 how many times? 2 times. 9 times 2, it's 18. So when we subtract, we get a 2. So this is the quotient. The remainder is also 2 and the divisor is 9. So we write it in this form, Q, R, D. The quotient is 2, the remainder is 2, and the divisor is 9. So this is the answer. This is the mixed number. The next question. Keep the first fraction, change the division symbol to multiplication symbol and flip the second fraction, which is the reciprocal of the fraction. 5/8 is written as 8 over 5. So multiply the numerators together. 7 times 8, 56. 11 times 5, 55. This can't be reduced because there's no other common factor and these are also co-prime. 56 and 55 are co-primes because there's no other common factor other than 1. The last question. Negative 4 sevenths divided by 5 over 14. So keep the first fraction, change the division to multiplication sign, and flip the second fraction. So we write it as 14 over 5. Multiply the numerators together, multiply the denominators together. 4 times 14 is 56 because one number is negative, the answer is negative. 7 times 5 is 35. We could reduce this by 7. 7 is the greatest common factor. So 56 divided by 7 is 8 and 35 divided by 7 is 5. This is yet again an improper fraction because the numerator 8 is larger than the denominator. You could convert this to a mixed number by dividing 8 divided by 5. 5 divides 8 just once. So when you subtract, you get a 3. So the answer is 1, 3 over 5, and this is a negative fraction. This is the answer, which is in terms of mixed numbers. The next question, you have to show that 1 over 2 plus 3 over 4 times 8 over 3 is equal to 1 over 2 times 8 over 3 plus 3 over 4 times 8 over 3. So you have to take care that you perform multiplication first and then addition. And always when you have these kind of equations, divide this as the left hand side and the right hand side of the problem. So let's begin doing the left hand side. So first we do what is there inside the bracket, the innermost bracket. So we are following the order of operations here. It is 1 over 2 plus 3/4. And we have looked into the addition rules, right? We have to have the common denominator. These two denominators are different. I could make 2, 4 by multiplying it with 2. But I also should multiply the numerator by 2. 1 times 2 is 2 and 2 times 2 is 4. So the new fraction formed is 2/4 and the old one is 3/4. I don't have to do anything with the second fraction because the denominator is already 4. 2 plus 3 is 5, and we copy the denominator, so it's 5 fourths. Now we have to multiply this with 8 thirds. For multiplication, you don't need to have common denominators. It's easy. 5 times 8, 4 times 3. 5 times 8 is 40, and 4 times 3 is 12. And this could be reduced by 4. The greatest common factor is 4. 40 divided by 4 is 10. 12 divided by 4 is 3. This is an improper fraction. You can just change that if needed. But let's do the right-hand side first. So on the right hand side, we have both of these sets. The first set is 1 over 2 times 8 over 3. Multiplication, as you know, it's very easy. Multiply the numerators together and multiply the denominators together. 8 times 1 is 8 and 2 times 3 is 6. And this could be reduced by 2. So 8 divided by 2 is 4 and 6 divided by 2 is 3. It's reduced to 4 thirds. The next set, 3 fourths and 8 thirds. So it's the same strategy. Multiply the numerators together. 3 times 8 is 24. 4 times 3 is 12. And 24 divided by 12, it's a whole number 2. Now we have 4 thirds and 2. So these are to be added. As you know, a whole number could be written as a fraction as over 1. Because any number divided by 1 gives back the same number. Now, the problem is you have to make the denominators common. We have 1. How can I make 1 look 3? I have to multiply 1 by 3. Only then I can make 1 as 3. So it's also important that I multiply the numerator by 3. Keep the first fraction and you then multiply the second fraction's numerator by 3. 2 times 3 is 6. The second fraction's denominator by 3. 1 times 3 is 3. Now we have common denominators. We can add the numerators and we can just copy the denominator. 4 plus 6 is 10. 10 over 3. While you just pay close attention to this, the right hand side also yielded an answer of 10 thirds, and the left hand side also we have 10 thirds, which means that the left hand side is equal to the right hand side, which is 10 thirds, and hence proved. The next question, simplify the following using distributive property. So this distributive property is a very interesting property. It is also called as a rainbow property. Say for instance, if you have the variables a, b, and c, you just multiply the first term with the first and the first term with the second. A times b is ab and a times c is ac. Because you have a positive sign here, this is turning out to be positive. If that was a negative sign, that would be a times b, which is ab, minus a times c, which is ac. So this is what is called the distributive property. The letter a is being distributed to the terms inside the parentheses, which are b and c. So it is distribute. We are distributing a to both of these terms inside the brackets, a to b and a to c. So likewise, we have to do the same here. 7 ninths is to be multiplied by 6 sevenths, and 7 ninths should also be multiplied to 3 fourths. So let's do that. 7 ninths multiplied to 6 sevenths, bring down the subtraction operator, and 7 ninths is multiplied by 3 fourths. So as you know, we multiply the numerators and the denominators together. 7 times 6 is 42, 9 times 7, 63, 7 times 3, 21, 9 times 4, 36. We have to simplify these fractions. You could see that 42 over 63, 42 over 63. What could be possible a factor which would divide both of these numbers? Let's try with 21. 21 times 2. 2 times 1 is 2 and 2 times 2 is 4. Yes, it works with 42. Let's try with 63. 21 times 3. 3 times 1 is 3 and 3 times 2 is 6. Yes, it works with 21 as well. So when we divide these by 21, 42 divided by 21 is 2 because 21 divides 42 twice. And 63 divided by 21 is 3 because 21 divides 63 thrice. So we have 2 thirds in this fraction. And the next fraction, you could also simplify this as well because there exists a common factor, 21 over 36. You could see that these are multiples of 3. So let's divide by 3. 21 divided by 3 is 7 and 36 divided by 3 is 12. So 7 twelfths is the answer. Now we have to make the denominators common before we subtract. So what should be multiplied by 3 so that it looks 12? It is 4. 3 times 4 is 12 and 2 times 4 is 8. And now the denominators are common. 8 take away 7 is 1, and we copy the denominator. So the final answer is 1/12. The next question, find the rational number x such that 5/6 of x plus 3/5 equals 5/6 x plus 1/2. So we have to prove and also show what is the value of x. So expand the left hand side as we did in the previous one, apply the distributive property. 5/6 times x is 5/6 x. 5/6 times 3/5 is 5/6 times 3/5. So remember, the operation that exists between this fraction and the terms inside is multiplication. So we are entitled to multiply. So once we are done with this, we can multiply these fractions. 3 times 5 is 15. 6 times 5 is 30. We are done. This is the left hand side and this is the right hand side. Before we compare the left hand side with the right hand side, we still can simplify this fraction. So when you see that 15 and 30, there exists a greatest common factor because 15 times 2 is 30. So which means that 15 divides 30 twice. So I can divide both of these values by 15. 15 divided by 15 gives me 1 and 30 divided by 15 gives me 2. So this fraction is reduced to 1/2. If you now compare the expression on the left hand side to the expression on the right hand side, they are exactly the same, which means that both sides are identical. Therefore, x could be any rational number since because both of these sides are identical. With that, we come to the end of this exercise. And thanks for watching.